Welcome to Real Civil YouTube channel. In this video, I am going to discuss with you the key concept from the unit bending of the beams. So what we are going to learn in this video is what is neutral plane, what is neutral axis, what is sagging bending moment, hogging bending moment, and uniform and non-uniform cross-sectional area. So here you can see I have drawn one beam. This is a two-dimensional structure, and suppose if we apply the load on the beam, so what is going to happen? Yes, obviously the beam is going to bend. So let's draw the deflected shape of the beam. Okay, so assuming the moment is sagging bending moment, we'll explain later. So this could be the shape of the beam. Okay, so you can clearly see the top fibers are getting compressed and the bottom fiber are getting in tension. So here you can see the fibers in that area, as I have shown you, they are compressed, so their length gets shortened, and the fibers in this area, they are get in tension, so their length has increased. Okay, so this is the general phenomena. So some fibers are getting compressed and some fibers are getting in tension. But very importantly, there exists one plane which is not going to be in tension, which is not going to be in compression. That means the length of that fiber is going to same, and the area in that plane is also not going to change before bending, even after bending. Okay, so here you can see I have drawn one neutral axis. Okay, and if you look at in the section, it will show you the neutral surface. So commonly or the area is not going to change for that plane before and after bending. So that is the key concept. Okay, so you can see here I have drawn a 3D view of the beam. Okay, so I have shown one plane. As you can see here, that plane is called as neutral plane. Means the area of that plane is not going to change before and after bending. It will be same. Okay, the plane above which the area will reduced, and plane below which their area is going to be increased. Okay, so a simple definition of neutral surface is a plane whose dimension will not change upon the application of the bending. Okay, now here I have marked the cross section in red color. So the neutral surface is meeting the cross section. That line we referred as a neutral axis. So here you can see this is our neutral axis. Okay, so simple, where the neutral plane is meeting the cross section, transverse cross section, that axis is called as neutral axis. So that is the definition of the neutral axis. The intersection of neutral surface and transverse cross section is called as neutral axis. And that is the definition of neutral surface. So I hope the picture is self-explanatory. What is neutral axis and what is neutral surface? So let's discuss about the next concept, sagging and hogging bending moment. So again I have drawn here a beam. The first beam, we have applied a moment and the direction is shown. Okay, this is our neutral axis. Okay, so due to the application of the moment, my beam is going to bend. Okay, so this is the direction of the movement. Okay, obviously the top fibers are going to compress and the bottom fibers are going to be in tension. Okay, So here you can see these are the shortened lens and these are the extended lens. So for this type of behavior, we call this as a sagging bending movement. So if you draw the neutral axis, it will something look like an happy face. So we will consider this as a positive bending movement or a sagging bending movement, right? So this is sign convention positive for calculation purpose. Okay, and you on your right side you can see I have applied a reverse movement. Okay, so obviously the bottom portion is going to compress now and the top portion is going to be in tension, as you can see in the figure. So the neutral axis shape you can see here you can see the movement that I have applied. So I'm bending in that direction. So the bottom fibers are getting compressed. Here you can see. And the top fibers are getting in tension. This is exact reverse behavior, opposite behavior. So you can see the neutral axis will be something like this. So it is like a sad face. So we consider this as a negative. This is where you can remember. So this is hogging bending movement. On your left side it is sagging bending movement. So you can imagine. Now we are going to discuss the next and the last concept, which is symmetric and asymmetric cross section. So here you can see I have drawn one rectangular cross section. I have shown the neutral axis. If the top fiber distance from the neutral axis is y1 bar and the bottommost fiber distance is y2 bar, and suppose if y1 bar is equal to y2 bar or y1 is equal to y2, then we call this as a symmetrical cross section. And if it is not equal, then we called unsymmetrical cross section. So this is the last point that I wanted to discuss with you people. The definition of symmetric and asymmetric cross section. I hope the concept is clear. If you have any doubt, you can ask me in the comment section. I will surely reply. Thank you so much for watching the video. Please like, share, subscribe the channel.